Hi, Transitional Math. This is your first video. Here's after looking through some of the stuff you guys sent me, / what we talked about, what people were tripping up on. So first, idea of trees, super important, right? So if I have like 5 books on a bookshelf, we'll call them A, B, C, and D and E. Then I can make a tree showing my choices. So in the first row will be my choices for book number 1 on the shelf. So book number 1 could be A, B, C, D, or E. And then if I choose one of those, let's say I choose B as book number 1. Well then, for my next set of choices, I'll have my next row. 4 choices, right? I'll have either A, C, D, or E as my next choice. And then after I choose my second book, maybe I choose book C, then I'll have 3 choices for my next one, A, D, or E. And then if I choose A for my third one, I'll have a choice of D or E. And then if I choose E for my second to last one, I'll have D for my last choice. And so we can make a full tree, 1, 2, 3, 1, 2, 3, 1, 2, 3, where we have all the possible options. Then we can count the number of trees that we're going to have, or the couple of the different combinations that we're going to have. So it looks like I'll have, for each first choice, I'll have 4 of my next, right? For the second choice. So I have 5 choices to begin with. And for each of those 5, right, I'll have 4. So there'll be 1 times 4, 2 times 4, that's 8 choices, 3 times 4, 4 times 4, 5 times 4 choices. So 5 times 4 represents all the choices I could have had here, right? 1, 2, 3, 4 times 1, 2, 3, 4, 5. So 4 times 5 for my first 2 choices, right? And then after that, it looks like those 4 will each have 3 choices. So for every 4 I have here, I'll have 3 choices. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. 3 here for all those, 3 here for all of these, and so on and so forth. Uh-oh, I bumped my camera. Hold on. There we go. Cool. All right, so after I choose those choices, that gets me up to here. You'll notice that each of those 3 choices is going to have 2 choices. So 2 choices from this one, 2 choices from that one, 2 choices from that one. Did it again. Got this thing put together with a rubber band right now. $400 to buy a new one, so I'm trying not to. But we'll see. Maybe this year I'll have to buy one. All right, let's try that. All right. So 3 choices for each of these 4. I had 1, 2, 3, 4 choices. Each of those had 3 options. And then each of those 3 has 2 options. 2 there, 2 there, 2 there. And for every 2 that I have here, right, D, E, or whatever, right, I have 1 choice after that. So in total, I have 5 times 4 times 3 times 2 times 1. That's going to be 60 times 2, which is 120. And the shorthand for this is 5 factorial. That's what this represents right here. 5 times 4 times 3 times 2 times 1. And the reason I really wanted to bring this up is because there's a way to generalize this. So if I have a number with a factorial symbol after it, what that means is I'm going to take that number, whatever that number is, just like 5 factorial, we took 5, and I'm going to times it by the number before 5, right? So here's 5, and I'm timesing it by the number before 5. So the way we represent that is this. If n is my number, then if I take away 1 from n, I found the number before n. So what this represents right here is the number before n. And that makes sense. If n is 5, then n minus 1 is 4. If n is 12, like I have 12 factorial, then I'll have 12 here, and then I'll have 12 minus 1 here. 11 will be the next number, right? And I'll keep doing this 2 numbers before 5. So 2 numbers before 5 would be 3, right? 5 minus 2 is 3. So 2 numbers before n is what this represents. So if we have 12, then 12 minus 1 is 11, 12 minus 2 is 10. We go on and on and on until eventually we end up multiplying by n minus n minus 1. So instead of subtracting 1 to get the number before n, 2 to get the number 2 before n, we're going to subtract n minus 1. Now remember what n minus 1 represents. N minus 1 is the number before n. So this is n minus the number before n. So in our case, it'd be 5 minus the number before 5, or 4, 5 minus 4. And of course, what is 5 minus 4? 1. If n was 12, if we had 12 factorial, we have 12. 12 minus 1 is 11. 12 minus 2 is 10, on and on and on, until eventually we got to 12 minus the number before 12, or 12 minus 11, which is 1. So basically what this means is that we're going to keep subtracting down until we get to n minus n plus 1. Because if you distribute that negative sign, these n's go away. We're going to go down until we get to 1. That's what factorial means. Keep multiplying by the number before it until eventually you reach 1. And we can represent it with this formula here. So when you see something like this, you might think, oh, that is factorial. Now, one of the things that was confusing, and this is the last thing I think I'm going to talk about for this one, was when we see something like this, how do we solve something like this in our head? This is one of the exercises I had you guys do. Well, 9 factorial means this. And 8 factorial, of course, means the exact same thing, except you might notice it's missing the beginning 9, right? And so if we're dividing and there's no addition or subtraction, we can divide out common factors. So this big number, whatever it is, has a factor of 8. And this big number also has a factor of 8. So they can divide out. That's what it says to do, divide. And of course, 8 divided by 8 is 1. Same thing with 7 divided by 7, 6 divided by 6, 5, 4, 3, 2, 1. You'll notice everything divides out and becomes 1. Not 0, but 1. And so, without having to figure out what the giant top number is or the giant bottom number is, we can see that our answer when these divide out is that all we're going to get is 9 times a bunch of 1s in the top divided by a bunch of 1s in the bottom, or 9. So 9 factorial divided by 8 factorial is 9. Another problem that's similar to this is the question 9 factorial minus 8 factorial. Now notice here, things divided out because we're dividing, right? That makes sense. If we're dividing, things are going to divide out. But if we're minusing, things don't divide out. So think about what this means. This means 9 times 8 times 7 times 6 times blah, 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 times eventually 1, right? That's what this means. That's 9 factorial. And then we're minusing whatever 8 factorial is, which of course is 8 times 7 times 6 times 5 times blah, blah, blah. Eventually we get to 1. So when we subtract these, things aren't going to divide out. And things aren't going to cross off because we're subtracting from this. So let me show you why like those 8s won't just cross off and become 0, because 8 minus 8 is 0. Imagine I had 4 times 3. Now let's do 4 times 8 minus 4 times 3. You wouldn't say the 4's just go away and you get 8 minus 3 is 5, right? Because 4 times 8 is 32, and 4 times 3 is 12. Ooh, that's 20. It's not 5. However, you might notice this is 8 4s minus 3 4s, so we're left with 5 4s, otherwise known as 20. Again, 8 4s minus 3 4s is 20, or 5 4s. We've talked about this in Algebra 2, but you'll notice they have a common factor, right? This term and this term both share a factor of 4. So I can rewrite this as 4 times the quantity of 8 minus 3. A lot of you are familiar with distribution, right? 4 times 8 minus 4 times 3, right? This is just the opposite of that. It's pulling out, right? Or factoring out a 4. So when I take out that 4, what I'm left with is 8 and negative 3, because 4 times 8 is the same thing as 4 times negative 3, or minus 4 times 3, same thing. So what we're going to do is we're going to look for, since we have 2 terms here, because there is a minus sign, right? 2 separate terms, unlike this, all one term. We're going to look for common factors. Well, it looks like we can take out an 8 from both, but we can also take out a 7 and a 6 and a 5. In fact, we can take out all of this and all of this from those two terms. So what am I taking out? I'm taking out 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. In other words, I'm taking out 8 factorial. That's what this is here and here. And what I'm left with then, 8 factorial times 9 would get me this. 8 factorial times 9 is this. Minus 8 factorial times, well, 1, not 0. Because, of course, 8 factorial times 0 would be nothing. 8 factorial times 1 gets me this. So, in other words, this is the same thing as 8 factorial times 8. And that will be our answer for this. 8 factorial times 8. So there is a distinction between these two problems, and it's important that you see what that is. Two terms, what can I take out? I can take out 8 factorial from both, so I'm left with 9 and 1. Here, I can divide out 8, 7, 6, 5, 4, 3, 2, 1, and so all that's left is 9. Again, two terms because there's a minus sign versus one term because there's no minuses or pluses. And that's it for this week's video.